Howdy IB, it's Miss Kosh. I made a lovely video talking about sine diagrams and then discovered that my microphone wasn't turned on. So that was fun. Okay, so the sine diagram, basically it's going to take, you're making a number line that shows where the graph has positive and negative y values. Okay, so what we care about is when the y value is 0. So if you notice on this one, at -3, I have a 0. And we care about asymptotes. So to show that there's something different happening, we'll use kind of a little dotted line. Sometimes I forget the dotted line. We shouldn't forget the dotted line, so do the best you can. And on this one, you'll notice from here that we can't let x equal 2. We have an asymptote there at x equals 2. So this one's great because we can see what's happening. So our y values are negative, then they're positive, then they're negative, and we're done. And that's the sine diagram for that first one. Now, if I didn't have, I should have probably called this f of x. If I didn't have the picture, it gets a little bit more complicated, but not much, okay? So what I would do in this case is I would say, okay, well, what is f of 0? So I would come and look and say, well, f of 0 is equal to a negative divided by a negative. And to be honest with you, I shouldn't even write these numbers. I don't even care. A negative divided by a negative equals a positive. And so this interval right here that has 0 in it is going to be positive. If I have f of, now I need something on the other sections, say -4. This is going to be, when I plug in -4, I have a positive 4 minus 3 is a positive, divided by a -4 minus 2 is a negative, and this is equal to a negative, and that's how I got that negative sign there. We would also find, it could be that they alternate negative, positive, negative, but it might not, so it's not a bad idea to pick a number on the other side, in that other interval. And I find that this is equal to a negative divided by a positive, which is equal to a negative, and sure enough, that matches what we saw from the graph. Okay, let's look at another one. Notice what we care about here are zeros and asymptotes. In this one, we don't have any asymptotes, but we do have a 0 at -1, we have a 0 at 0, and we have a 0 at 3. And we're going to go, what am I? Negative, positive, negative, positive, based on what I see in the graph. When I come over here, let's call this g of x, just to change it up. If I wanted to say, okay, what's g of -5? Well, when I plug in -5, I don't care what the value is. I just care positive or negative. And so when I look at this, -5 is going to give me a negative, that's going to give me a negative, that's going to give me a negative. And if I have a negative times a negative times a negative, it stays negative. And sure enough, -5 was over here, and I wrote a negative right there. I could keep going, but I think you understand what's happening. This next one is a little bit more interesting. Let's pretend that we can't see this for just a second. I know you can, but whatever. What I see is I would see that I have domain restrictions at 1 and -3. So -3, oh, I see, I'm telling you, I do it wrong every time. I forget, well, not every time, but a lot of times. So I want to show that it's an asymptote. And I want to also show that, what was it, -3 and +1. And I also want to see about any zeros. So when I look at my denominator, x minus 2 equals 0, it can when x is equal to 2. So I'm going to have a 0 here at 2. So what I would do is I would check to see what's happening. Let's call this h of x, just to change it up. Let's say h of -4. That gives me a negative divided by a -4, that gives me a negative, that gives me a negative divided by a negative times a negative, there's 3, this becomes negative, and sure enough, right here, it's negative. Okay, then we need to look at something in between, so let's try h of 0, and so when I plug in 0, I get a negative divided by a negative times a positive. That's going to give me a positive. Sure enough, it's positive. When I keep going, I have between, well, 1 and 2. Okay, 1.5. All right. So I don't like to work with decimals and fractions unless I have to. 1.5 minus 2, that's a negative, divided by 1, that's a positive times a positive. So that's going to be a negative right here. Let's try 3. And that's a positive divided by a positive times a positive, which is a positive. And sure enough, that matches our graph. Okay, go practice the worksheet I gave you on sine diagrams. Enjoy.